Hello everyone, welcome to this live session. And in this live session, we solve this nice math Olympiad algebra problem. Or usually, this types of problem will be lies in the exams of university entrance exam. Okay, like Harvard University, Oxford University. Okay, so further we solve this problem for three methods. I hope so you like all of these three methods. But if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And here we move towards in our first method. So in first method, we just use here the nice algebraic formula into the left hand side. And here in the first method we use this nice formula. You know about that. If we have a plus b whole square is equals to a square plus 2 times of ab plus b square. Okay, so here in this formula, we just apply this nice algebraic formula into the left hand side of the above equation. So after applying this formula into the left hand side, our left hand side is written as in this form. So here you see that this will be written as a square plus 2 times of a into our b is 5 and plus b square. So here our b is 5 square and this whole equation is equals to 25. So further in the next step, we need here more simplifications. And now you see that we have this is a square plus 2 times of 5 becomes here 10 times of a plus this is 5 square, and 5 square is equals to 25, and this whole equation is also equals to 25. And further in the next step we need to move this 25 to the right hand side, and it will be written as a square plus 10 times of a is equals to this is 25, and when we move this 25 to the right hand side it will also becomes minus 25 because this is the positive term. When we move it into the right hand side it will becomes negative. And further in the next step you see here this negative 25 is cancelled out by this positive 25, and we have we get the remaining values are from here we get a square plus 10 times of a is equals to 0. And in the next step we have you see here both of these two terms involve a, so that we need to take common a from here, and when we take common a we get the remaining values are here we will get here we get a plus when you take common a from here we get 10, and this whole equation is equals to 0. And now here in the next step you see we need to divide this equation into the two cases. So the first case is we will write here our a is equals to 0, and the second case is we write a plus 10 is equals to 0. So further you see here this is our first root of the given equation, and from here we get the second root, and when we move this plus 10 to the right hand side it will becomes a is equals to minus 10. So this is the second root of the given equation. So in the first method we will get here these are the two roots of the given equation. And in the next step we need to just verify that is both of these two roots are satisfied our given question statement or not. So for verification of the roots, we need to copy down given question statement here. So our given question statement is a plus 5 whole square is equals to 25. So this is the our given question statement, and in this side and here first we need to verify a is equals to 0. So in order to verify a is equals to 0, this means that we need to substitute a is equals to 0 into the left hand side and we check its behavior. So when you put a equals to 0 on here, it will be written as 0 plus 5 whole square is equals to 25. And here we check that after substituting the value of a equals to 0 is both of the sides are equal or not. So that here 0 plus 5 becomes here 5 square is equals to 25, and we found that 5 square becomes 25 equals to 25. So this shows that the value of a is equals to 0 is satisfied our given question statement because both of the sides are equal in this case. And further in the next step, we need to verify our second value of a. So that our second value of a is equals to minus 10. So that we need to put this value of a into the left hand side of this equation. So that when we put this value here, it will becomes this is a plus 5 whole square, and when we put a is equals to minus 10 plus 5 whole square is equals to 25. And now in the next step we have minus 10 plus 5 is equals to minus 5 whole square is equals to 25. And now here again you clearly see that minus 5 square becomes here because the square of negative term becomes positive, so that's why we write minus 5 square becomes plus 25 is equals to 25. So this also shows that the second value of a is also satisfied our given question statement. So this means that we have there are two solutions of the given equation. So we will write here the solution set in the first method is that we have 0 and minus 10 be the solution set of this given equation, given quadratic equation. So this is the final answer. And now here we again solve this problem for second method. But you remember that in this live session we solved this problem for three methods. I hope so you like all of these three methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move towards our second method, and in the second method we need to copy down given question statement here. The given question statement is a plus 5 whole square is equals to 25. So in the second method we use another algebraic formula in order to solve this quadratic equation. So here we need to first rewrite this equation as, so for this we move this 25 to the left hand side and it will be written as a plus 5 whole square. This is positive 25. When we move it into the left hand side it will become negative 25, and this whole equation is equals to 0. And here we again rewrite this equation as a plus 5 whole square minus we write this 25 as 5 square, and this whole equation is equals to 0. So further in the next step we use here another nice algebraic formula. You know about that. If we have a x square minus y square is equals to x minus y times of x plus y. So according to this algebraic formula, we write here our above equation as in this form. So here our above equation is a plus 5 whole square minus 5 square, and if you see here, the base of this term is our x and the base of this term is our y. So here we need to just substitute these two values of x and y into the below formula. So after substituting these two values into the below formula, it will be written as, here our first factor is x minus y. The value of x is a plus 5 minus the value of y is 5 only, into the second factor is x plus y. So the value of x is a plus 5 and plus the value of y is 5 only, and this whole equation is equals to 0. And now here further in the next step we need more simplifications, and it will be written as, this is negative 5 and positive 5 are cancelled out by each other, and we will get here a only, and from here we get a plus, this is 5 plus 5 becomes here 10, and this whole equation is equals to 0. And in the next step, we need to divide this equation into the two cases. The first case is we will write here a is equals to 0, and the second case is we write a plus 10 is equals to 0. So from here, this is the our first root of the given equation, and from here we get the value of a is equals to minus 10. So this is the second root of the given equation. So you see here in the second method we again get these are the two roots of the given equation, and now here in the next steps we need to verify that is these two roots are satisfied our given question statement or not. So here for verification of the roots we need to copy down given question statement here, and the given question statement is a plus 5 whole square is equals to 25. So this is our given question statement, and here we need to verify these two values of a, and we check that is these two values of a are solution or is these two values of a are extraneous roots. So for this first we choose here our a is equals to 0, and now we need to substitute a is equals to 0 into the left hand side of the above equation, and we check its behavior. So when you put it here, it will becomes 0 plus 5 whole square is equals to 25. And further you see here 0 plus 5 becomes here 5 square is equals to 25, because here we just check that is this is both of the sides are equal or not. So this 5 square is equals to 25 equals 25. So this shows that the value of a is equals to 0 is satisfied our given question statement. So this means that a equals to 0 be the first solution of the given equation because it satisfied our given question statement. And now here we again we verify our second root, and our second root is a is equals to minus 10. So for verification of this root a is equals to minus 10, we just substitute a equals to minus 10 into the left hand side of the given equation. So when you put it here, it will becomes minus 10 plus 5 whole square is equals to 25, and here again we check that is both of these two sides are equal or not. And now here for this we have minus 10 plus 5 becomes here minus 5 square is equals to 25 or not. This is the our claim, and we know about that when we take the square of negative term it will becomes here positive. So it means that minus 5 square becomes here positive 25 is equals to 25. So this means that both of the sides are again equal. It means that the second value of a is equals to minus 10 is also satisfied our given question statement. So it means that both of these two values are satisfied our given question statement. So it means that the solution set of the given question is 0 and minus 10, because both of these two values are satisfied our given question statement. And now here we move towards our third method. So here in the third method, we need to copy down given question statement here, so that our given question statement is a plus 5 whole square is equals to 25. So this is our given question statement, and here in the third method we will use the square root technique to solve this problem. So here, in order to use the square root technique, this means that we need to apply square root on both of the sides, so that when we apply square root on both of the sides, it will be written as in this form. And now you see here, these two and this square root are cancelled out by each other, and after cancellation of these values we will get here our remaining values are, so from here we get a plus 5 is equals to, and in the right hand side we know about that the square root of 25 is equals to 5. Further, you know about that when we apply square root on both of the sides, we will write here plus minus sign on any one of the side. So that we just write here plus minus sign into the right hand side. And now further we break this equation into the two cases. So in our first case is we write here a plus 5 is equals to positive 5, and our second case is we write a plus 5 is equals to negative 5. So these are the two cases. And now here in the first case, we need to move this plus 5 to the right hand side, and when we move this plus 5 to the right hand side, it will be written as a is equals to, this is plus 5, and this plus 5 is also becomes here minus 5, because this is positive into the left hand side. When we move it into the right hand side, it will becomes negative, and this is minus 5 and this is plus 5 are cancelled out by each other, and we will get here our a is equals to 0. This is the our first root of the given equation which we get here. And now we move towards our second case. And in the second case, we again move this plus 5 to the right hand side, and it will becomes a is equals to minus 5. This is positive 5. And when we move it into the right hand side, it will also becomes here negative, and we will get here our a is equals to minus 5. Minus 5 becomes here minus 10. So this is the our second root of the given equation. So here in the third method, we again get these are the two roots of the given equation. And now here further in the next step, we need to verify that is these two roots are the solution, or these two roots are the extraneous roots. So for verification of the roots, we need to copy down given question statement here, and the given question statement is a plus 5 whole square is equals to 25. This is the our given question statement. And now here first we need to verify a is equals to 0. So in order to verification of a is equals to 0, we just substitute a equals to 0 into the left hand side of the given equation. So when you put a equals 0 here, it will becomes 0 plus 5 whole square is equals to 25. And we know about that 0 plus 5 becomes here 5 square is equals to 25, and here you clearly see that 5 square becomes 25 is equals to 25. So this means that the value of a is equals to 0 is satisfied our given question statement, because both of the sides are equal. And here further we need to verify our second value of a, so that here we substitute a is equals to minus 10 into the left hand side of the given equation. So when we put this value here, it will be written as this will becomes a plus 5, and our a is minus 10 plus 5 whole square is equals to 25. And here you see that we have minus 10 plus 5 becomes here minus 5 whole square is equals to 25. And here we again see that uh, here we can see that minus 5 square becomes here 25, because when the negative sign appears inside the square root sign, it will always becomes here positive. So this the square of minus 5 square becomes plus 5 square, so 25 is equals to 25. This shows that the value of a is equals to minus 10 is also satisfied our given question statement. So this means that in the third method we again get the solution set of the given question is 0 and minus 10. So this is the our final answer of this problem. So here for your practice, we again solve another problem in the form of x. You know that if we have x plus 3 whole square is equals to 9, then you need to find all the values of x. So here we again solve this problem for three methods. So here we start towards our first method, and in the first method we need to move this 9 to the left hand side, or in other words we just rewrite this equation as in this form. So we have this will be written as x plus 3 whole square. This is positive 9. When we move it into the left hand side, it will becomes negative 9, and this whole equation is equals to 0. And here again you focus on 9, and we write here our 9 as 3 square, and this whole equation is equals to 0. And further here we use another nice algebraic formula. You know about that. If we have a square minus b square is equals to a minus b times of a plus b. So here we use this nice formula. So you see here the base of this term is our a, and the base of this term is our b. So we just substitute these two values of a and b into the below formula, so that we write here our given equation according to the below formula as in this form. So here we have, first you have a minus b. The value of a is x plus 3 minus the value of b is 3 only, into again we have a plus b. The value of a is x plus 3 plus the value of b is 3 only, and this whole equation is equals to 0. And further in the next step we have, this is minus 3 and this is plus 3 are cancelled out by each other, and we will get here x times of this will becomes here x plus 3 becomes here 6, and this whole equation is equals to 0. And now here further we divide this equation into the two cases. The first case is we will write here x is equals to 0, and the second case is we write x plus 6 is equals to 0. So this is the first root of the given equation, and from here we get the value of x is equals to minus 6. This is the second root of the given equation. So here we get these are the two roots of the given equation. And now here further in the next step we need to verify that is both of these two roots are solution of given equation, or both of these two roots are extraneous roots. So for verification of the roots, we need to copy down given question statement here, so that our given question statement is x plus 3 whole square is equals to 9. This is our given question statement, and here first we need to verify x is equals to 0. So in order to verify x is equals to 0, this means that uh, we just put x is equals to 0 into the left hand side of this equation, and when we put this 0, it will become 0 plus 3 whole square is equals to 9. And we know that 0 plus 3 becomes 3 square is equals to 9, and 3 square becomes 9 is equals to 9. So this means that the value of x is equals to 0 is satisfied our given question statement. This means that x is equals to 0 be the first solution of the given equation. And now here we move towards our second value of x, and the second value of x is equals to minus 6, and now we verify this value so that we put x is equals to minus 6 into the left hand side of this equation. So when we put this here, it will becomes minus 6 plus 3 whole square is equals to 9. And now you see here minus 6 plus 3 is equals to minus 3 whole square is equals to 9. And you know about that, minus 3 square becomes here 9 is equals to 9, and this shows that the second value of x is also satisfied our given question statement. So this means that finally we have the solution set of the given question in this method is that 0 and minus 6. So this is the solution set of the given equation which we get here from first method. And now we again solve this problem for second method. So in second method, we need to copy down given question statement here, so that our given question statement is x plus 3 whole square is equals to 9. This is the our given question statement, and here in the second method we use the radical or square root technique to find the values of x. So here in order to find the values of x from second method, we just apply square root on both of the sides of this equation. So when you apply here square root, it will be written as in this form. So this 2 and this square root are cancelled out by each other, and we will get here our x plus 3 is equals to, we know that a square root of 9 is equals to 3. But here you remember one thing is that when we apply a square root sign on both of the sides, we will write here plus minus sign on any one of the sides, so that we will write here plus minus sign into the left hand side, into the right hand side, sorry. Okay, so further we need to break these values into the two cases. The first case is we write x plus 3 is equals to 3 positive value, and the second case is we choose the negative right hand side. It is x plus 3 is equals to minus 3. And in the next step we need to first solve the left hand side, and here we need to move this plus 3 to the right hand side, and it will becomes x is equal to 3 minus 3. So this will be written as x is equals to, this is negative 3 and positive 3 are cancelled out by each other, and we will get here x is equals to 0. So this is our first root of the given equation, and now here in order to find the other roots, we need to move this plus 3 to the right hand side. And when we move this plus 3 to the right hand side, it will be written as x is equals to minus 3. And when we move this plus 3 to the right hand side, it will also becomes here minus 3. and from here we get the value of x is equals to minus 3 becomes here minus 6. So this is the value of x, second value of x. So here we get these are the two values of x, 0 and minus 6. And in the next step we need to verify that is this value of x is satisfied our given question statement or not. So for verification of this, we need to copy down given question statement here, and it is x plus 3 whole square is equals to 9. So this is the our given question statement, and in this side first we will be verify x is equals to 0. So it means that we need to substitute x is equals to 0 on both of the sides of this equation. So here when we put x is equal to 0 into the left hand side, it will be written as 0 plus 3 whole square is equals to 9, and we know about that 0 plus 3 becomes 3 square is equals to 9, and 3 square is also written as an is also equals to 9. So it means that we have 9 is equals to 9. So this means that both of the sides are again equal when we choose x is equals to 0. So in the same pattern we need to verify the second root of the given equation, and our second root is x is equals to minus 6. So here we will write x is equals to minus 6. So in order to verification of this root, we need to put this value of x into the left hand side of the given equation. So when you put this value here, it will be written as minus 6 plus 3 whole square is equals to 9, and here we need to subtract these two values. So minus 6 plus 3 becomes here minus 3 whole square is equals to 9. So here you know about that when we take a square of negative term, it will always becomes here positive. So minus 3 square becomes here 9 is equal to 9. So this shows that the second value of x is equals to minus 6 is also satisfied our given question statement. So finally we have the solution set of the second method is that 0 and minus 6. So this is the solution set which we get here in first method. This is the same solution set which we get here into the first method. And now here we move towards our third method. And in third method, we need to again copy down given question statement here, and the given question statement is x plus 3 whole square is equals to 9. So in the third method, we use here the nice algebraic technique or algebraic formula to solve this problem. So here we use this nice formula. You know about that. If we have a plus b whole square is equals to a square plus 2 times of ab plus b square. So if you see here, our a is x and our b is 3. So according to this, we apply here the formula into the left hand side. So after applying this formula on here, it will be written as x square plus 2 times of x into 3 plus 3 square is equals to 9. And further we have this is x square plus 2 times 3 becomes 6x plus this 3 square becomes 9 is equals to 9. And again we need to move this plus 9 to the right hand side, and it will be written as x square plus 6x is equals to this is 9, and this plus 9 is also becomes minus 9. And you see here this is negative and positive term are cancelled out by each other, and we will get here x square plus 6x is equals to 9 minus 9 becomes 0. So here we need to take common x from here, and when you take common x, we get the remaining values are x plus 6 is equals to 0. So here we divide this equation into the two cases. The first case is we will write here our x is equals to 0, and the second case is we write x plus 6 is equals to 0. So this is the first root of the given equation, and from here we need to move this plus 6 to the right hand side, and it will becomes minus 6, and this is the second root of the given equation. So in the third method, we again get here these are the two roots of the given equation, and also in the first and second method, we already verified that both of these two values of x are satisfied our given question statement. So finally, we have the solution set of the given question is that 0 and minus 6. So this is the our final answer of this question, and I hope so you like all of these methods. And thank you so much for watching this video. So please subscribe to my channel for more exciting videos. But here at the end, I can just give you an assignment which is related to this type of question, and I hope so